2.0.0, making wire connections. Explain how to complete wire connections. Describe how various connectors are installed. Explain how to assemble aluminum connections, and explain how to install control and signal cables. And then there are performance tasks that your instructor will want you to do. NEC Section 110.14 governs electrical connections, including terminations and splices, where connections are used to connect wire or cable to electrically operated devices such as motors and pumps, as well as control circuits of all types. So here's a highlight. It says the range is normally stamped on the tongue of each terminal. So these barrel lugs, they're saying that on the tongue of the connector, there it should be stamped. You can just barely make out that this one is stamped. It should tell you the wire range that you can put in this barrel, this terminal. Mechanical compression connectors are available to accommodate wires from number 8 gauge through 1000 kc mil. 1-hole lugs, 2-hole lugs, split bolt connectors, and other types are shown in figure 19. So this, of course, is a 1-hole lug, and this is a 2-hole lug. Okay. Some of them are good for 2 conductors. They're a 2-hole or a 2-barrel lug. They said they were going to show us a split bolt. This is a split bolt. It literally looks like somebody took a bolt and took a saw and cut the middle out of it. It has this nut, and the nut has a retaining little table on top of it where you can put big conductors inside of this, and then as you tighten the nut, it's going to compress it between the top of this split bolt and this table. They're going to compress the two together. And the way I was taught is you put them together and you tighten them with your channel locks, and you get them as tight as you can tighten them. And then you take either your channel locks or a hammer. I guess you're supposed to use a hammer, not your channel locks. And you literally take the connections with the split bolt and you smack it. Smack, 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 smack. And those vibrations cause the wires in the split bolt under pressure to move. They're malleable. It's changing the shape of them. Their shape is taking on the shape of the hole in the split bolt. And after you smack them around for a little while, you take your channel locks and you tighten them some more. And then you smack them a little bit more and you tighten them a little bit more. Get them to where you cannot tighten them by hand with channel locks. You don't use cheater bars. You don't do anything that's going to damage the cable. You don't want to break the strands of copper by applying too much pressure. You don't want to crush them. You just want them to take on the shape of the internal space of the split bolt. But you smack them, you tighten them, you smack them, you tighten them. And you might smack them 5 to 10 times. Smack, 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 and then tighten them. And then smack them again and tighten them. Smack, tighten. Once you get them to where they no longer tighten up any, then you can tape them off with electrical tape and rubber tape and some friction tape. And finally, one last layer of the electrical tape to hold everything together. And it's a good connection. All right. So this is a crimp type reducing connectors used to connect 2 different wire sizes. So that reducing connector is a connector used to join large conductors to smaller ones. All right. Parallel tap conductors with an insulated cover shown in figure 19 is an example of a pre-insulated molded mechanical compression connector. There are several kinds available. They come in set screw, pressure plate, insulation, piercing configurations, made for use with a variety of feeder tap and splice applications. Because they're equipped with an insulating cover, the requirement for taping the joint is eliminated. Where is figure 19? They said they showed it to us. Okay, this one, this one has a plastic cover that goes over it. Once it's tightened down, you can snap this in place, and like they say, there's no need to insulate it. There are other types that are rubber coated. The entire thing is rubber coated. You can put the wires in and tighten them up, and then when you get done any open holes, like where you tighten these hex heads, they have a plug, and you put the plug in the holes, and it makes them completely insulated. Tightening compression connectors, screws and bolts. Here they're using a torque wrench. Mechanical compression connectors must be tightened to a specified torque using an approved tool per NEC section 110.14d. Over tightening can cut into the wires or break the fittings, while insufficient torque leads to a loose connection. Don't guess, use the right tool to set the correct torque. So they're going to talk to us about torque. They're going to talk to us about mechanical and electrical strength. Insulating connectors. Task of fastening a connector to a wire requires the use of the proper connector, tool, and procedure. Always use the correct tool for the connector and follow the connector manufacturer's instructions. Installing compression connectors. Here's a highlight. It says the point of intersection C represents the ideal crimp force. Here's another highlight. It says using a crimping die that is too large results in poor electrical performance. So they have a graph here of mechanical strength. This blue is the mechanical strength. And you see you get to a good mechanical connection before you actually get to a peak electrical connection. And we don't want to tighten it only to the peak mechanical. We don't want to over tighten it to the peak electrical connection. We want to hit this sweet spot where we have the maximum amount of mechanical strength and electrical continuity. So that's the intersection point C. They're saying that's where you want to tighten it to, right here. You're going to start losing some of your mechanical strength while at the same time you have not yet reached the peak of the electrical continuity, but that's the sweet spot. That's what we're going for. So, simple handheld crimping tool was the first crimping tool developed, and it continues to be used for repair operations and simple installations. This is calibrated so that you close the jaws completely. And whichever one of these you're using, you close the jaws completely, and it's supposed to put the right amount of pressure on that crimp. There are others that are ratcheting. There are still others that have a release mechanism that when you get to the right force, the jaws will automatically open up. The amount of tool multiplies the hand force by is referred to as mechanical advantage. So you're putting 10 pounds of force and it's actually delivering 50 pounds of force. So mechanical advantage is a multiplier applied to the force a worker manually applies to a crimping tool to determine the total force applied. These I'm going to say are not complete. You have crimping dies that you will insert in here. Depending on what size wire, you have to put a crimping die in there. Crimp die in the tool determines the completed crimp shape. A variety of configurations are in use, such as the simple nest and indenter type of die and the more complicated 4-indent die. Crimp dies are interchangeable and may contain 2 or 3 positions for crimping different size terminals. So, like this one, it's got crimping dies that you can put in here. You can change the size of the conductor. You can change the crimp configuration. I've seen a lot of hexagonal. It'll crimp from 6 sides at once, and it makes a very good mechanical strength crimp while maintaining a good electrical continuity. And again, this goes to a certain PSI. The tool is calibrated for it, and when you get to that point, it'll automatically open these jaws. These are actually hydraulic. There's some hydraulic fluid in here, so that as you pump this, it's going to bring this to a certain PSI, and once it gets there, this will just automatically, you'll feel it click. You'll bring the handles down, and then all of a sudden there will be a click, and it'll release this handle. Cordless crimping tools are now very popular, especially when many crimps need to be made. Figure 24 shows an example of a cordless crimper tool. So it runs on battery, and you can put different crimping dies in here for different size wire, and you can make your crimps. And again, you squeeze the trigger, it comes together, when it reaches the maximum PSI, it automatically releases. Then you have to release the trigger before it will activate again. Select a crimp connector from the proper size and appropriate material for the wire size you're using. Copper connectors should be used with copper wires, and aluminum connectors with aluminum wire. ALCU connectors may be used with both copper and aluminum. Use a suitable wire stripper to remove the insulation from the end of the wire. Clean the stripped portion of the wire. Use a wire brush for a large wire size. Obtain the crimping tool and dies designed for the type and size of connector. And then insert the stripped end of the wire completely into the connector. Position the crimping tool in place over the connector and operate the tool to complete the crimp as directed in the tool manufacturer's instructions. So this one has different lines on it, and it tells you to crimp at each one of these lines. You don't just crimp it once and walk away. This entire barrel needs to be crimped, and this crimping tool will crimp, and you can move it down and continue crimping. Some of them will do all of these all at once, and that's great. Some of them will do just a section of it, and you have to move the tool several times to crimp the entire barrel. Using the appropriate hardware, secure the crimped connector and attach the wire to the correct terminal. Tighten the terminal bolt and torque to the level specified by the equipment manufacturer. And then here's a table that lists some torque values. Again, I'm not going to waste our time looking at that. Mechanical terminals and connectors. Procedure for installing mechanical connectors is basically the same as that described as for the compression connectors, with the exception explained in the following paragraph. For installing mechanical connectors on the wire, apply an oxide inhibitor joint compound to the conductor to prevent the formation of oxide after the connection is made. This is especially true if you're using aluminum. Aluminum wires, you have to put this No-Lox or Penetrox. It's an anti-oxidizing agent, and you put it on the aluminum. As soon as you strip aluminum, it starts to oxidize when it's exposed to the air. And that oxidation makes it a poorer conductor of electricity. So you apply the antioxidant, the No-Lox, onto the aluminum. You're actually supposed to take a wire brush after you've put this paste on the end of the aluminum, and you're supposed to brush it in order to take off any oxidation that was there in the time you strip the wire and before you put the No-Lox on there. And then once you get it nice and scrubbed down with that wire brush, then you can put the barrel on that aluminum wire and tighten it down, crimp it, or if it's a mechanical lug, you tighten it by hand. Many cables require specifically designed box connectors, commonly called terminators, to secure them to the equipment enclosures. Specialized connectors are normally supplied with installation instructions. This section will introduce you to one type of specialized connector designed for use with MC cable. So let's see what they've got here. Type MC cable is a factory assembly of one or more insulated circuit conductors with or without optical fiber members. It's enclosed in a metallic sheath of interlocking tape or a smooth or corrugated tube. The use of type MC cable in cable trays and on racks instead of non-armored cable in conduit is steadily increasing. At the appropriate locations, the cables are routed from the trays or racks, then along the structure to the various loads. NEC Article 330 governs the installation of type MC cable. There are several types of connectors that can be used with type MC cable. All fittings must be listed per NEC section 330.6. So select the connector. The correct connector size is normally done by comparing the physical dimension of the cable to a cross-reference table given in the manufacturer's product literature. Strip back the jacket and armor of the cable as needed to meet the equipment requirements. Expose the cable armoring further by stripping the weatherproofing off the cable jacket for a specified distance as shown in figure 26. This distance will be found in the connector manufacturer's installation instructions. So this termination device, you're going to cut back the armored cable off of the conductors, and there's an internal you've actually taken off the weather stripping. This has some kind of like a rubberized coating. You take that off, and you cut this back to a certain length, and you put this on. It says entry component, end stop, O-ring, connector body. This is the retaining spring. 6 is the washer, 7 is a jacketed seal, and 8 is the compression nut. So as you tighten down on it, it's going to grab onto this and hold the jacket so that it's secured. And then the end is threaded. You can put it up through a hole in the box and put a lock nut on it. Make sure the jacket seal and retaining spring are in their compression state. If necessary, loosen the connector body and the compression nut. Screw the connector body onto the equipment or secure it with a lock nut if it has an unthreaded entry. Pass the cable through the connector until the armor bumps into the end stop. If it's not possible for the insulated wires to pass through the end stop, remove the end stop so that the wire can move past and the armor can bump the stop without the entry, within the entry component. Tighten the connector body to compress the retaining spring and secure the armor. It's usually tightened, hand tight, plus 1.5 full turns. Tighten the outer compression nut to form a seal on the cable jacket. Normally this is hand tight plus 1 full turn. If appropriate, terminate the individual wires contained in the cable using compression or mechanical connections. Then they talk about tightening torque. Make sure that you follow the manufacturer's instructions. Aluminum connections. This is what we were just talking about. This is where you have to use that no locks. Aluminum has different properties than copper, and special precautions must be taken to ensure reliable connections. For example, aluminum does not spring back when bent like copper does. It's more susceptible to oxide formation than copper. Aluminum has a different thermal expansion properties which can affect terminations. Because of these properties, standard copper connectors cannot be safely used on aluminum wire. Most manufacturers design their aluminum connectors with greater contact area to counteract some of these issues. The tongues and barrels of aluminum connectors are larger and or deeper than comparable copper connectors. The electrolytic action between aluminum and copper can be controlled by plating the aluminum with a neutral metal, usually tin. The plating prevents electrolysis from taking place and the joint is more likely to remain tight. Connectors should also be tin plated. An oxide inhibiting compound can be applied if desired or specified by the NEC. The NEC no longer requires it as it once did. Any insulating aluminum oxide film may be removed to create a reliable aluminum termination. However, the NEC no longer requires the conductor to be brushed to remove the oxides. It remains a reasonable practice, though, as many appear as a necessary step in job specification. Changes to the NEC regarding the handling of aluminum terminations are largely the result of a change to the aluminum itself. An aluminum alloy referred to as AA8000 is now used for conductors. NEC section 110.14 prohibits conductors made of dissimilar metals, copper and aluminum, copper and copper-clad aluminum, or aluminum and copper-clad aluminum, from being intermixed in a terminal or splicing connector unless the device is identified for the purpose. Following rules generally apply. Connectors marked with only the wire size should only be used with copper conductors. Connectors marked with AL and the wire size should only be used with aluminum conductors. Connectors marked ALCU may be safely used with either copper or aluminum. They're not saying you can put them both under the same terminal. A lot of times when you have a connector that connects copper and aluminum, it'll be a double barrel. And you'll put the aluminum on one side and the copper on the other side, and it joins them electrically without allowing them to have electrolysis between the two dissimilar metals. 2.3.0 Control and Signal Cables. Electricians install all the associated power cables and many of the signal cables for instrumentation systems in industrial facilities. It's necessary to select the proper type and rating of control and signal cables to meet the NEC requirements, local codes, and equipment manufacturer requirements for the system being installed. Except for optical fiber or communication cables that enter a structure and are terminated in an enclosure within 50 feet of the entrance, the NEC requires that control and signal cables be listed and marked with an appropriate classification code. Control and signal cables are type classified, rated, and listed for use in various areas of the structure in accordance with the following NEC articles. All right, so I'll let you look over these. I'm not going to read every one to you. Fire alarm instrumentation and control cables carry low-level signals that carry less current than power cables. Conductor sizes range from number 12 to number 24. Remember, that's smaller, depending on the circuit requirements. Conductors can be tinned or bared, solid or stranded, twisted or parallel. Shielding, if used, is usually an aluminum-coated mylar film with a drain wire or multiple drain wires inside a jacket. Jacket and conductor insulation are rated for the applicable usage. Figure 27 shows typical fire alarm and instrumentation cable. So here's instrumentation cables. These are fire alarm cables. They have this mylar film and this drain cable. And I think we discussed it earlier that drain cables are usually only terminated on one end, and that end is usually in the control cabinet. Out in the field, you'll take it and wrap it around this mylar film and then put a piece of tape over it so that it can't come in contact with anything. To be effective, the shielded drain wire must be grounded. The installation loop diagram or instructions for the system equipment will indicate how and where the shields are connected to grounded. Typically, only one end is grounded, and the drain wire at the other end is isolated by folding it back and taping over it. You know what? I'm going to highlight this part of it that says only one end is grounded. Okay. This prevents the electrical noise collected by the shield from recirculating through the system and interfering with control signals. 2.3.1 Crimp connectors for screw terminals. Low voltage control circuits typically use compression type crimp connectors. Compression type connectors for low voltage circuits can easily be crimped with handheld tools. Proper crimping action changes the size and shape of the connectors and deforms the conductor strands enough to provide good electrical conductivity and mechanical strength. All right. Here's a barrel lug. That's a ring lug. Notice this split. That's a seam. This was punched out of a flat piece of metal, and then these two were rolled up to create a sleeve. They're not welded. They're just formed into this circular barrel. So when you crimp, if you have a crimp tool that has a tooth, the tooth goes on this side. You want to fold this down onto the wire. If you were to crimp the opposite side, if you put the tooth on the bottom, it has a tendency to open this connector. You do it on the top so that it folds them down onto the wires. Okay, this being the opening on the top. You want to fold them down on the wires, not putting the crimp down here where it's going to cause the opening to open up and then the wires will splay out. And some of them are insulated. The insulated ones, you're not supposed to use the tongue. You're supposed to use a different type. All right. And again, the size of wire should be stamped on the tongue. Here's a highlight. It says information about the connector size and conductor range is usually stamped on the tongue by the manufacturer. The style most frequently used are the ring tongue and locking fork. So here's a ring tongue, and here is a locking fork or a flanged fork. They hold the screw much better than just a regular fork. If the screw loosens even a little bit, these can slide out. So most job sites want you to use a ring tongue where you have to remove the screw completely, and then when you tighten it, there's no way for this to come undone. It says red is usually used for sizes number 22 through 16, blue is 16 and 14, and yellow is 12, 10. So use the right size connector or termination device. These are terminal boards. Here's TB1, terminal board 1, terminal board 2, and then each wire has a sleeve on it telling what the wire number is. This is a very nice, neat job. Someone's done a really nice job. They brought the wires up or down in this panduit, and then they fanned it out of the side of the panduit and terminated it. And these are actually call out numbers that tell you where this is going and what it's doing. But that's a nice job. That's a terminal block. It has a screw. You put the wire underneath the screw and tighten it down. You don't have to crimp anything. You don't have to re-insulate it. The size and type of wire are correct. The connector and the wire material are compatible. Compare cable and lug designations for material type. It says make sure the correct crimp tool and die for the selected terminal are being used. Make sure the tool is in proper working order. A compression connector should be installed as follows. Now, I hate reading these long lists of instructions to you. I'm going to leave this for you to read. Just read these steps. I don't have any highlights, so let's see what these say. Amperage capacity. It's the maximum current that a lug can safely handle at its rated voltage. And grooming is the act of separating the braid and a coaxial conductor. All right. So I don't have any highlights in that area. 2.3.3 termination inspection. Final step of the crimping procedure is inspecting the termination to ensure that it is electrically and mechanically sound. It must be tight with no loose strands or uninsulated conductors showing. Inspect uninsulated terminal for correct positioning, centering, and crimp indent consistency. So here's a highlight. It says the crimp barrel is designed to provide the best mechanical strength when the indent is properly placed on the seam of the barrel. So that's what we were talking about, the tooth. You want that tooth to be on the seam of the barrel. That'll give you the best mechanical strength. And there's just a cross cutaway of it showing you what it looks like. And again, you don't want your strands to be sticking out further than about a 32nd of an inch. You do want them to stick out. You don't want them to be back behind the end of the crimp connector. So this one's good. And they're saying not to exceed a 32nd of an inch. I don't know that that's code, and I don't know that anyone's going to inspect you. If it was sticking out a 16th of an inch, I don't think anyone would tell you you have to redo it. So just know that they're saying a 32nd of an inch. Terminal lugs with a belled mouth must have the conductor insulation butted against the tapered end of the crimp barrel as shown. So the insulation of the conductor has to go all the way into this butt end of the barrel connector. Okay. Terminal block connections. Terminal block types vary according to the preference of equipment manufacturers and their suitability for application. 3 common types of terminal blocks are described as follows. These fit on a DIN rail. These you have to mount with screws, screw type terminal blocks, and these are clamp type terminal blocks. So it has a plate, and the hole is actually square. They do have pin connectors that will give you a square fitting that will fit in that square hole, and it gives you a very good connection when you tighten it down. These just the screw tightens up on the wire, either solid or stranded. And these are spring loaded. You shove the wire in and you're done. If you want to take it out, you have to depress this. You have to put a little blade in here and push down on the spring, and then it will release the wire and allow the wire to come back out. All right. Spring-loaded terminal block to connect the wire. Release the spring contact using a flat blade screwdriver and insert it into the hole on top of the block. After the wire is inserted, remove the screwdriver. The wire is held in place by a spring contact. Clamp type terminal blocks to connect the wire inserted into the boxes, the boxed terminal, and tighten the screw to clamp down on the wire. And then the screw type terminal block. Curve the wire around the screw or install a terminal lug that's inserted under the screw. Connectors with rings or forks are designed for this type of termination. Okay, so they're saying that the screw type, you need to put it underneath the screw either with a ring terminal or with a fork terminal. And again, most jobs are going to want you to use a ring terminal because they will not come off. Very good. Section 2 review. MA tools generally have a ratcheting feature and increased leverage using, I'll let you decide. Aluminum connectors are designed with greater contact area to counteract what? And the common color code for a number 10 gauge crimp is what? Okay, I'll see you on the next.